All right, so today we're going to talk about some base angles, equilateral, equiangular triangles, perpendicular bisectors, and the angle bisector theorems. All of these are some theorems that we've been using. We just haven't officially given them some recognition until now. So the base angles theorem, this only works with isosceles triangles. Remember that an isosceles triangle has two congruent sides. If we look at our picture over here on the right-hand side, the triangle would have base angles at 1 and 2. Those would be the angles that are congruent. The vertex would be at angle 3. The base angle theorem tells us that if those two angles are congruent, angles 1 and angle 2, then the two sides opposite those angles are also congruent. That just kind of goes along with the definition of what an isosceles triangle is. So here's how we use it. If we have a triangle GFH and we know that the angle at F is 48 degrees, we want to try to figure out what H is. Well, first of all, it's an isosceles triangle, so these two angles, angle G and angle H, are going to be congruent. That's by the definition of an isosceles triangle. So if we wanted to revert to algebra, we could put an X here and an X there because they're the same amount. And we would say X plus 48 equals 180 degrees because 180 degrees is how many degrees we have in a triangle. We can type that into Desmos. X plus 48 equals 180. X, let me zoom out one more time. X is 66. Now, some of you are probably saying, why didn't I just subtract 48 from 180 and divide by 2? Well, that works. Let's see what we get. Oh, if I can type stuff in right, 180, subtract 48. 48 equals 132, and 132 divided by 2 is 66. Yes, it works both ways. Another example you might run into is, I've got my isosceles triangle here. So that tells me that angle G and angle J are congruent. This go round, I'm going to say 3x equals x plus 44 because they're congruent. Now, I'm going to type that in. 3x equals x plus 44. X equals 22. Great. Is that my answer? No, that's not my answer. I have to substitute. I'm looking for angle G, which is x plus 44. So I'm going to substitute in 22, and I'm going to get that angle G is 66 degrees. Another problem says, find the value of x given that angle D is congruent to angle F. Angle D is congruent to F. Well, that means it's an isosceles triangle, so these two sides must be congruent. X is 9. Is that what I needed to find? Yes. So now we have this equilateral, equiangular theorem. I've been talking about this a little bit. This tells us that if we know the triangle is an equilateral triangle, then it's also an equiangular, and vice versa. So if it's equilateral, it's automatically equiangular. If it's equiangular, it's automatically equilateral. When we know that it is equiangular, then each of the three sides is 60 degrees. How can I prove that? Well, it's 180 degrees total, and it's 3 sides, so that means that each side is only 60 degrees. Here's how we would use this problem. If I have all 3 sides marked, that should automatically indicate it's equilateral, and that also means it's going to be equiangular. Each angle is 60 degrees. 2x plus 32 equals 60 degrees. If I'm looking for the value of x, I'm just going to type this into the Desmos calculator. X is 14. Is that what I was looking for? Yep, it sure was. Next problem says that I want to find the value of y. Well, all 3 of these angles are marked, and if all 3 angles are marked, it's equiangular. If the triangle is equiangular, it's also equilateral. So that means all 3 of the sides are the same length. Since they are the same length, I set them equal to each other. What am I going to get this time? Remember always to type in x. X is 18, so that means y is 18, and that's exactly what I was looking for. There we go. Next problem. Next problem says a perpendicular bisector bisects the triangle into 2 congruent triangles. So if you have a perpendicular bisector in a triangle, then it's going to make 2 smaller triangles that are congruent to each other. Line CD is a perpendicular bisector. There's our new word, perpendicular bisector. It cuts angle C into 2 congruent triangles. It also cuts that line AB into 2 congruent segments. And when that happens, that also means that segments AC and BC are congruent. They're kind of like mirror images of each other. They're a reflection of each other. So how do we do this? Well, CD is the perpendicular bisector of AB. Find CA and DB. Well, CD is the perpendicular bisector. So that means that it bisects, and I have 2 triangles here. Let's just mark them in pink. Those 2 triangles are congruent to each other, and then these yellow triangles are congruent to each other. So that means CA will be 5 and DB will be 6. I just have to look at those triangles and realize that they're congruent to each other, so their parts are going to be congruent. Here's another example, example 7. If I have 2 pieces down here at the bottom that are congruent to each other, that means they've been cut in half. I have a right angle, so that means something's perpendicular. And when that scenario happens, I can say that NP is a perpendicular bisector. That means that NL, which is 2.6, will be the same as NM, or MN, however you want to say it, 2.6. All right, I got the same setup in example 8. I've got a 38 and a 38, and I've got a perpendicular. That means that BD and DC are going to be the same length. So, I'm about to make a mistake. I wrote 12, but 12 is wrong. How do I know 12 is wrong? Because I didn't look at the problem. BD is 12. BC is BD plus DC, which would be 12 plus 12, and that's 24. So I almost made a mistake here. Make sure that you guys don't do that. The angle bisector theorem. The angle bisector theorem just says that it bisects an angle into two smaller but equal angles. When you make perpendicular line segments from that bisector to the original sides of the angle, which is what I'm trying to show you here in this picture, you can say those two segments are congruent. This kind of looks like a baseball diamond. It's not exactly it, but that's kind of what it reminds me of. In this picture, segment LY bisects AYB. So that ray or line segment is bisecting this angle down here in red, home plate. That means that AYL is going to be congruent to BYL. And that also means that the two segments, AL and BL, are also congruent. So how do I use this? All right, I've got my little diamond set up here. I've got two congruent angles. I've got some perpendicular lines. That means that I've got two segments that are going to be congruent. So 5x equals 2x plus 24. Five x equals 2x plus 24. X is 8. What was I trying to find? Well, let's see. I needed to find x, then find DF and BF. All right? What's DF? 5x. So 5 times 8 is 40. Well, BF should be the same thing because they're congruent segments, but let's do some substituting and see what happens. So 2 times 8 plus 24, 16 plus 24. Yep, that does give me 40. All right, last example. I've got to find the measure of angle MKL. So that would just be this one right here highlighted, MKL. That's kind of hard to see that. There we go. Is that a little bit better? So those two angles are congruent. So 2A plus 26 equals 3A plus 20. Now when I go to Desmos, remember, I have to use an X instead of an A. But we've been doing that the whole time, so you guys should be used to that by now. X is 6, so A is 6. And now what am I doing? MKL is 2A plus 26, so 2 times 6 plus 26. 2 times 6 plus 26, 38. So angle MKL is 38 degrees.